We are talking about properties of logarithms. We want to use properties of logarithms and expand and condense logarithmic expressions. So here we're given approximation log base 5 of 3 and log base 5 of 6, and we want to use those values, those approximations, to evaluate the following. So we don't have a log base 5 of 81, but we have 6 and 3. So we got to find some way that we can make 81 become either 3 or 6. And I do know that we could say the log base 5 of 3 to the 4th power. So 3 to the 4th power is 81, so that's the same. Now we could use our log rules where we have our exponent here. And if we have the exponent, we can move it out in front of the log. So we can write it as 4 log base 5 of 3. And now we can substitute in our approximation. So we can say 4 multiplied by the approximation of log base 5 of 3, and that is 0.683. And that is about equal to 2.732. We use our calculator. We can look at next example here, and again, we don't have one for 1/6, but we do know 6. So is there a way we can write this? And we have division, so yeah, we can separate that using subtraction. And so we can write this as log base 5 of 1. Then we have the minus sign, and log base 5 of 6. Now we can examine this a little bit before we move on, because this is a little bit different. If we take a look at this one here, and we can say, just going to rewrite it, log base 5 of 1, and we'll say that's equal to y. Well, another way that we can write that is we can say 5 raised to the y power is equal to 1. So in this case, what would y have to be? In this case, y would have to be 0, because 5 to the 0 power is 1. So log base 5 of 1, that whole thing is ends up being just 0. So we can have 0 minus, and then we can substitute in the log base 5 of 6, which is 1.113. And so that ends up being, I guess this should be an approximation as well, because we substitute an approximation there. And so that should be negative 1.113.